Welcome to the afternoon session. And now in this session, we are going to explain about what is ESC, how are you supposed to choose a ESC subject, what are the credentials or criteria to choose a ESC subject, etc. For that, let us start me with introducing what are the ESC subjects you have. As you can see on the screen, you have these five ESC subjects labeled as ESC 1. First one, building sciences and mechanics. Next, introduction to electrical energy. Next, introduction to electronics and communication engineering. Essentials of information technology. Now, out of these five subjects, these subjects are supposed to choose in such a way that you are to complete two of these courses in the first year of your engineering. And to choose them, there are some criteria. Like, for example, as you can see, the first subject, that is ENSC 104A, Building Sciences and Mechanics. This subject will be taught by Civil Department. The students who are not joined civil engineering, okay, the students who have not joined civil engineering are able to take up this course. For example, if you are from electrical, electronics, mechanical, or any CS and allied branches, you can choose civil. Similarly, introduction to electrical can only be chosen by non-electrical students. Like, for example, if you are taken EEE as your engineering, you cannot choose introduction to electrical engineering, but you can choose either one of building sciences, electronics and communication, mechanical engineering, and information technology likewise. Okay, so I think you understood the idea. And now, for example, say you are a CS student, you chose building sciences and mechanics in the first sem. Then in the second sem, you are now not to choose building sciences and mechanics, but you can choose electrical, electronics, and mechanical. Essentials of information technology is taught by CS itself. Therefore, a CS student now restricted to take up essentials of information technology also. I'll explain again. Listen to this carefully. This is very, very important because the link for choosing your ESC subjects will be sent once you come for the offline classes. So listen to this. Now, giving an example of CS, a CS student cannot choose essentials of information technology in both the semesters. He can only choose the first four. And out of those first four, he'll choose one in the first sem and one among the other three in the second sem. Now, if you choose as building sciences in the first sem, then the CS student has to choose electrical or electronics or mechanical. Likewise, if you are an electrical student, you can't take up introduction to electrical engineering, but you can take building science or electronics or mechanical or essentials of information technology. Similarly, electronic student cannot take electronics and communication engineering, but you can take the other four. Likewise, you have to complete two of these four courses. Out of the five options, you get only four. And out of those four, you have to complete two courses, one in the odd sem, one in the even sem. Now, to explain it to you how these courses are useful for you, we have this representative faculties from each department who would be engaging the session for you for about 15 to 20 minutes of time, and they'll be explaining about the given subject stream. Okay, so now let us start with the first one, building sciences and mechanics, which will be given up by Mr. K.S. Jayadip, Assistant Professor, Department of Civil Engineering. Jayadip sir, you can start and present.
Yes, sir. Am I audible, sir?
Yes, sir, you are audible. You can start.
Yeah, one second. So, yeah, good afternoon, everyone. This is Jaydeep speaking from the Assistant Professor from the Department of Civil Engineering. So I'll be giving an overview of the ESC course, Building Science and Mechanics, which will be offered from the Civil Department. So this course is open to all the first year engineering students, except for those who are from the core civil engineering branches, which means a student who has chose civil engineering as his branch cannot study this subject, but other students who have opted for different branches, maybe mechanical, electrical, CSE and allied branches can choose these subjects. So in a couple of minutes, we'll be discussing about why, as a um, student from not civil background, why you have to study this subject. So if you are from a mechanical, electrical, electronic, CSE and allied branches, this course will help you understand the concepts that connect your branch to the real world engineering problems, so that it's not only just about buildings or the construction of it, it's about
Ma'am,
learning the language of engineering that all disciplines share. So now I'll be sharing my screen.
yes, sir.
Yeah. So sorry for the delay. So yeah, the first question will be now what you will be studying. So now let us see that what you'll be studying in this course. To look into this, this course is divided into 5 modules, where you'll be learning about different topics of civil engineering and its science and how construction goes on. So in the first module, it will be about the introduction to the building science, where it's about the basic concept of what is civil engineering and what are the different areas of civil engineering. To summarize it, it will be just like a tour of how civil engineering connects to the world around us. It's about basic civil engineering things. Now, the second module is on the sustainable and built environment. So here you'll be learning about eco-friendly materials and how we can build a sustainable environment by reducing the damage to the environment in a very sustainable way. Then, in the module 3, you'll be learning about how forces act and interact. So, if a structure is constructed for its intended purposes, it has to experience through a lot of forces. Then, when there is a force acting on the structure, there will be a counter reaction or an interaction between the force and the structure, which has to be evaluated for a sustainable building. So in that way, we have to evaluate about the force system. Once you know about or you understand about how forces act, the next step is to see how these structures stay in balance when these forces are applied. So this is what you'll be learning about the things in the module force, or basically you can say when a force acts on the structure, how to balance it or how to counteract it, that you will be learning in the module 4. And in the fifth module, we'll study about the basic centroids of the plane area. Why? Because a balance of a structure depends on its centroid, and so on you will be learning about the centroid of the structure. So this subject is a very basic and an overview on how it is very much important. Now let us go to the next thing, that is the course outcome. So ultimately, what is the outcome of this course? As a non-core branch student, why after learning, what is the outcome? So in that way, we can say you'll be learning about the you'll be able to explain about the fundamental concepts of building science. You'll know what is civil engineering, what basic construction materials we are using, and what are the structural elements of a building. And the thing is how sustainability affects things, all those. And in the third and fourth module and the fifth module, you'll be learning about the forces acting on the structure and how to balance the structure. So in that way, in a short way, you can say you'll not just know how buildings are made, but also how they stand, how they can be sustainable, and how engineers analyze them mathematically. So it is the collaboration of all the engineers in making a building sustainable one and a long durable one. So the next question would be why as a non-IT non-civil student. So thing is it is a collaborative effort from all the branch students. So the first one will be it's about the structural analysis. If you take a mechanical engineer or an aerospace engineer or robotics engineer, he'll design a suitable system. A structure is also a system in that way. So his effort will be very much required in analyzing the structures in the sense. Next is about the material science. So in the second module, as we have discussed, we'll be discussing about the sustainable materials. Way of sustainable materials, it becomes for us to choose a sustainable material. So in that way, what is a sustainable material we have to choose, and how it goes on with the different buildings aspects. All of this we have to address. So there comes the parts of electronics engineer, a mechanical engineer, where selecting a suitable sensor, a mechanical part in terms of material science. Then it's about the sustainability and environmental impact, which is a critical uh, issue for all the engineers to develop an eco-friendly system, in energy efficient system, to reduce environmental footprint, make environment a sustainable one. So in that way, it is the role of all the engineers. Contribution is required. Next thing is the smart systems and IoT. If we take an example of any apartment that is constructed so far, we will be generally fascinated by its design and the overview. But the thing is, we also keep in mind is how smart these buildings are. Maybe from entering the building using automated sensors, that is without the need of security guards, all automated one. So in that way, the role of an computer science engineer, AML engineer, or an electronics engineering in developing such integrated systems, where he has to develop some programs where if a car enters the building, the park gate should automatically open, where a mechanical engineer will also play a role. So in that way, it is the role of all the engineers in the civil engineering field. And as we have discussed, it is about the project management and a collaboration effort. So whenever we need to build a sustainable environment, it becomes the role of all the engineers. So that is why you need to opt, or you need to understand about this course. So one more important question would be for you is, apart from what is the topic is, will I be able to achieve my desired CGPA or SGPA after studying this course? Yes, you will be able to achieve whatever the target you have set very easily, because the course is very much simpler. It is nothing but understanding the basic science of construction, where you will be applying your technology to the science that is already present, in making the science very much simpler in the building. So we'll be providing the quality study materials through hard copy or soft copy through Google Classrooms. There'll be regular doubt clearing sessions. We'll conduct even the tutorial classes for numerical problems. And whenever there is an internal assessment test or a CAE test, a pre-class unit test will be conducted for your preparation, so that there won't be any doubts before you go inside the exam. Next thing is, what is the overall pass percentage? From the past 2 years, we have got a very good results. We have got 100% results in this subjects, and students have easily scored 95% of the marks out of the 100 marks. So it is very much a basic course, so you can opt for it. So if you have any doubts, you can contact me or any other faculty from the civil engineering department, and you can clarify any of this. So I wish you all a happy learning.
Introduction to Electronics, and this subject can be chosen by the students who are joined civil, electrical, mechanical, and computer science. For that, to give the introduction for you, we have with us Mr. Srinivas Babu sir. He will be giving me the explanation regarding Introduction to Electronics and Communication subject. Over to you, sir.
Yeah, good afternoon. Masha, before I can start, can you see my screen in full screen mode?
Yes, sir. It's visible. You can just go to the next slide. I will let you know if it is moving or not.
Now?
The screen did not move, sir.
Okay,
The next
screen
slide
is
did
not.
not move. You can just go
Okay,
back.
I'll share my entire screen. I think.
Okay, sir.
Now? Can you see now? Slide moving?
Yes, sir. Not yet. I'll just, yeah, slide is moving, sir.
Okay, thank you. Thank you. Good afternoon, all my future students. Okay, my name is Srinivas Babu. I'm assistant professor in the Department of Electronics and Communication. So my job here is to sort of lure you all into selecting this subject as your ESC course. Okay. So as the sir has already told you, this is emerging science course. It is offered both in first as well as second semester. So the name is Introduction to Electronics and Communication. The subject code is BENSC 104C in first semester, 204C in second semester. Okay. Next, before going through the syllabus, I just want you to give a reason why we should study this electronics and communication subject. Okay, why anyone should study this subject? Okay, either as a ESC course or as a ETC course or as a core course. Okay, right? Or in simple words, why electronics is needed. Okay, so I'll give you the latest reason why anyone should be interested in studying electronics. Okay. So as per industry estimates, the size of Indian semiconductor market was about $38 billion in 2023. Okay. And currently it is at $50 billion in size. Okay. And do you know it is expected to reach $100 billion by the year 2030. Okay. The global semiconductor market is around $600 billion currently, and it is expected to reach 1 trillion US dollars by 2030. Okay. So in that $1 trillion market size, India is going to occupy a significant portion in 2030. I'll tell you why. Because India has launched Indian Semiconductor Mission, ISM in short. I'll repeat, India has launched India Semiconductor Mission in December 2021 with an outlay of 76,000 crore rupees. That means the Indian government has plans to spend 76,000 crores of rupees to provide financial support in semiconductor fabrication, display manufacturing, and chip design. Okay, right? So you will have a lot of opportunities as a graduate, as a person who wants to pursue career in electronics, or the person who wants to start a company or startup. Okay, all these people are going to have huge opportunities in the near 5 years. Okay, in the future. Okay, so that is the reason why anyone should be interested in studying electronics. Okay. Next, after that, I mean, if you want more details, I urge all of you, I insist all of you to search Indian Semiconductor Mission in Google. So there is a website that has been launched especially for this purpose, dedicated website. The address is ism.gov.in. Okay, so you can get all the information, what the government is planning to do and what they've been doing. Okay, all the information you can get it on that website, ism.gov.in. Recently, you would have seen in the newspaper that a Semicon 2025 has been concluded, and in that, our Prime Minister has said that India's semiconductor drive is to make the nation self-reliant. That means we have to make our country self-reliant. We don't want to be dependent on any other country, and we also want to be globally competitive. That means we would like to export all these chips, semiconductor chips as well. So that is his mission, and the government is spending massively, right, to fulfill the dream. Okay, so that is the reason why anyone should be interested. Next, coming to the importance of this subject, before we can understand the importance, let me just ask you a question, right? Can we imagine our daily life without computers, internet, and mobile phones, right? Or similar such devices. Okay, let's stick to these three: computer, internet, and more importantly, the mobile phones. Right? The answer would be a unanimous no. Okay, right? We can't imagine our lives without these devices, these technologies. Okay, right? There are many more technologies like this, but these three are the most important. That's why I have mentioned them. Okay, and all these technologies are partially, I would say completely, partially are possible because of electronics and communication. Okay, right? So that is the reason why, right, this subject, this course is so important. Okay, but even non-EC students, it is so important. Okay? Now, what you will deal in electronics and communication, okay, right? What we are dealing with. So we'll be dealing with electronic devices like diodes and semiconductors. We'll be dealing with circuits, okay, right? ICs, integrated circuits, right? And we'll also deal with communication, right? Like analog, digital, right? Of data, voice, video, right? The popular example being AM, FM, radio, D2H, which we're all using in our day-to-day lives, cellular communication, the 5G or 4G, whatever you're using, right? And then the microprocessor and microcontrollers and embedded systems, right? These are also very, very essential part of our lives. Okay. Antenna and wave propagation, and then most important for internet. Probably without internet, this would not have been such a success. I mean, internet would not have been such a success without optic fiber communication, optic fiber cables. Okay. So we'll be understanding, right, all these things, right, better if we can take up this course. I mean, it also, electronics and communication also includes current technologies like robotics and automation, Internet of Things, I would in short, 5G, right, 5G communication, AI hardware. A lot of us believe that AI is only about software, but AI is also about hardware. So what kind of hardware, what kind of processor we need for AI, right? That also we can understand, can learn and discuss, okay? Then satellite communication. Recently, satellite communication is also, right, becoming part of our daily lives because it is providing internet facility in many countries, and soon it's going to be launched in India also, okay, right? So this is the importance of this subject. Okay. So with this background, let us now go back to the objectives, right, that we have in our institution, right, as why we need to study this, right? These are the course objectives, right, of this subject, right? This is the objective we would like to achieve by the end of this course, okay? So by the end of this course, right, we will facilitate the students to learn, right, the following 5 things. Okay. First is operation of semiconductor diode and rectifiers and fundamental knowledge of amplifiers. I'm sure if you would have studied in your either in your 12th PUC or in your 10th standard somewhere about semiconductor diodes and rectifiers. Okay, so we are going to study in detail about the semiconductor diode and the rectifiers, and more importantly amplifiers. Okay, in this course. Okay, this is the semiconductor diode is the beginning of the semiconductor industry. Okay, electronics you can say. Okay, right. So semiconductor diode are in simple words, PN junction diode is the basis of all the electronics. Okay, all the electronic devices are made from semiconductor diodes. Okay, and then are in other words PN junction. Okay. Next, you will be able to learn transistor. Again, transistor is one more very important electronic device which people should understand, right? Understand how it works and how you can use them for building devices and equipments. Okay. So we'll learn transistor operation. When I say transistor, we restrict ourselves to only BJT. That means only BJT, bipolar junction transistor will be taught. Okay, so only BJT we will study. Okay, we'll study the types of BJT. I'll tell more about the transistors in the syllabus. Okay, so first, sticking to course objectives, so we'll study transistor operation, working of oscillators. So I'll be telling more about oscillators in the next slide. Operational amplifier, we call them as op-amp in short, and its application. So that is the second objective. The third objective is logic circuits. Logic circuit means electronic circuits can be divided into two types of circuits. One is analog circuits and the other one is digital circuit. Logic circuit basically means digital circuits. Okay, right? And how we can design a digital electronic circuit, I mean logic circuit, that also you will be able to understand. Okay, you can easily design a logic circuit, that we will see right, in the next slide. The fourth objective will be, will acquire knowledge about embedded system. What is an embedded system? Uh, where it is used, okay, what is IoT, right? So that also will be our objective, that is fourth in our list, okay. Then the last is to gain knowledge about electronic communication, because communication is an essential part of electronics. So without electronics, probably whatever communication we have today wouldn't have existed in the first place. Okay, right? So electronics and communication goes hand in hand. Okay, that's why the branch of our, the name of our branch is electronics and communication. Without electronics, there won't be any communication. Okay, and then different modulation techniques. So there's a process called modulation in communication. So that also you will be able to learn. So these are our course objectives. Next, moving on. This is the syllabus. Okay, I have shortened it because of shortage of time. Okay, we will study much more. In brief, this is the syllabus. We have 5 modules and we'll spend at least 8 hours per each module. First module, as I said, is semiconductor diode and power supplies and amplifiers. So we'll be studying about semiconductor diode, PN junction diode, power supplies and amplifiers. Okay, right? So in this module, we'll be discussing PN junction diode, rectifiers, all types of rectifiers, filters, voltage multipliers, okay, Zener diode, right? And how we can use Zener diode as voltage regulator, that also we'll be discussing, okay. And then we'll be discussing amplifiers in the same module, module 1. Amplifiers are again a very, very essential part of any modern day communication tool. Without amplifiers, our communication, even the telephone would not have existed in the first place. Forget about cellular phones, mobile phones. Telephone became very, very popular mainly because of the amplifiers. We'll discuss about amplifiers, the parameters related to the amplifier, and we'll be discussing about negative feedback. Negative feedback is an essential component in amplifier. So we'll be using negative feedback in amplifier, positive feedback in oscillator. Okay, that we'll discuss. And we'll discuss multi-stage amplifier, right? Because single stage amplifier, one single amplifier is not sufficient to provide the required amplification. So we need multiple stages of such amplifiers. That also we'll discuss. Okay. In module 2, we'll discuss about oscillators and operational amplifiers. In short, operational amplifiers are called op-amps. Okay, right. So first, before oscillators, we'll be discussing about the transistor. I told you, right, just before, we'll be discussing only BJT, bipolar junction transistor. Okay, we'll be discussing its operation, what are its types. As some of you might be knowing already, there are 2 types mainly in BJT. One is NPN and PNP. Okay, and we'll be learning the symbols, right, of those 2. Okay, and then we'll start with the oscillator. So oscillator is basically a circuit which generates a sinusoidal AC signal. Okay, need not be sinusoidal, but you can say AC signal. You can generate AC signal by applying a DC voltage, right? Without any input signal, just by applying DC voltage, we can generate AC signal. Okay, it can be sine, it can be square, it can be triangular, sawtooth, anything. Okay, right? So that we will discuss how we can make oscillator, right? Because oscillators are very, very important component in electronic circuit. For example, if you have worked with microcontroller boards or even in your mobile phone, right, every device work with a frequency. Okay, right? So that is the frequency of the square wave, right, generated by the oscillator. That means all these devices will have an oscillator. Okay. And we'll discuss what are the different types of oscillator. There are basically the 3 types of oscillator we need to discuss. One is, as I said, crystal oscillator, which is widely used in every device, every electronic equipment. Okay. And then a Wien bridge oscillator, second one. The third one is called ladder oscillator. Okay, right. And we'll also discuss multi-vibrator. Multi-vibrators are similar to oscillator, but you can say that it is a part of oscillator. It is a subset of oscillator, multivibrators. They only can produce square wave. Okay, right? So their operation, their area of operation is restricted only to generally to square wave. Okay, right? So we'll see the operation of a single stage astable oscillator. Okay, right? Which is basically nothing but a multi vibrator. Multi vibrator oscillator. The main difference is multi vibrator only vibrates or operates between two levels, high and low level, whereas the oscillator, the voltage level can vary, right, from 0 to, let's say, 5 volts, or it can even be negative voltage also. Okay, right. Next, uh, the same module will study the most important component, that is operational amplifier. Okay, in short, we call them as op amps. Okay, right. Op amps are nothing but analog electronic circuits, right? Op amp is basically an IC. It's called as a linear IC. There are two types of IC. One is linear IC and the other one is digital IC. It's a linear IC. It's an analog IC. Okay. So we'll briefly discuss about op amps in module 2. Its parameters, what are the parameters associated with op amps, gain, bandwidth, input impedance, all those things. And then what are the characteristics of op amp, and then what are the configurations, and what circuits we can make out of this op amp, that also we'll discuss. For example, we can easily build an adder, we can easily build an amplifier, inverting amplifier, non-inverting amplifier, a differentiator, integrator. All these circuits can be built by using op amp. So that is module 2. Moving quickly to module 3. Module 3 is all about Boolean algebra and logic circuits. So Boolean algebra, some of you might be already aware, or most of you will be aware of Boolean algebra, I guess. It's part of mathematics. Okay, right? This is basically used in ICs or in digital logic circuits. Okay, right? So Boolean algebra, again, there is a difference between Boolean algebra and real algebra. We'll discuss that when we start our classes. Okay. Uh, I'll tell you, right, in simple, Boolean algebra is a subset of real algebra. Okay. In Boolean algebra, we'll be discussing with uh, values in real range. That means the value can be negative, can be positive, it can be zero also, right? But in Boolean algebra, there are only two values available for variables, that is 0 and 1. Okay, and there are limited number of operation in Boolean algebra. In real algebra, you can have all sorts of operation, addition, subtraction, everything, multiplication, division. In Boolean algebra, we have very limited number of operation. All of you know, I guess, if I say, you can easily relate. You have AND operation, you have OR operation, and you have NOT operation, right? So that is Boolean algebra. Okay. And logic circuits which can be built by using Boolean algebra. Okay, how to build logic circuits and how can we build combinational logic circuits. Again, in logic circuit we have two types, combinational and sequential. We'll be discussing combinational logic circuits. For example, we'll be discussing how to design an adder. Okay, there are again two types of adder. One is half adder and the other one is full adder. Right? How to design half adder or full adder, we discuss. Okay. We'll be discussing number system also. Okay, number system. Basically, there are four number systems, right? We are familiar with three, or many of us only are familiar with one, that is decimal number system. We also have binary number system. There are only two digits. We are aware of about hexadecimal number system, and there is one more called octal number system. So these four number system will discuss, and we'll see the conversions. Okay, how to convert number from one number system to other, from decimal to hexadecimal or hexadecimal to binary. So that is number system conversion. We discuss that also. Very easy topic. Okay. Boolean algebra, as I said, right? There are a lot of rules and theorems, right? We'll be discussing in Boolean algebra, and then digital logic gates. Okay, so all the gates, right? Logic gates like AND, OR, NOT, XOR, all these gates we'll be discussing NAND and NOR. Okay, in this module. And finally, as I said, we will be able to design with all this information. We'll be able to design an adder. Okay, from the scratch. Okay, that is module 3. Quickly moving on to module 4. embedded system and IoT. Earlier, this module was only having embedded system and some sensor and interfacing. But now sensors have been removed, and in accordance with the VTU syllabus, we have added IoT. Yeah, so IoT is the new thing. Okay, even for us. Okay, so this time was first time we have IoT in the basic electronics and communication. Okay, so coming to embedded system means it's related to microcontroller. There are two types of computers. One is general computer and the other one is embedded computer. Okay, embedded computer means any computer with a chip inside. Okay, right? That means embedded systems are generally devices, right? Every device which has a microcontroller or microprocessor inside is an embedded system. Okay, so that examples are washing machine, refrigerator, air condition, right? So all these things. Okay. So we'll be discussing about embedded systems in module 4. What are the different types of embedded system we have? Major area of application, right, where we use these embedded systems. Okay, that also we'll be discussing. Okay, so uh, I think I have got a message to wind up quickly. I'll go quickly. We'll be discussing the difference between microprocessor, microcontroller, RISC, all these things. Okay, as I said, what is an IoT device? Basic building blocks of IoT device also will be covering in this module. Module 5 is all about communication, uh, analog communication schemes and digital modulation schemes. So there are two types of communication, analog, digital. We'll be discussing only analog communication in module 5 and digital modulation technique. Modulation is a different kettle of fish. We'll discuss it. Okay, this module is mainly about communication, right? How communication happens, right? What all we can communicate, voice, data, image, video, all those things, right? So what ways we can communicate. So all these things we'll discuss. We dedicate this module for that. Okay. This is the syllabus. These are the uh, prescribed reference books, prescribed textbooks are textbooks actually, 5 of them, right? That I'll go quickly, right? So all 5 books will be very, very helpful. Okay, right? And then this is the assessment details. So we'll have a CI for 50 marks and SE for 50 marks, total 100 marks. So tests will be conducted for 50 and 2 tests basically, and it will be scaled down to 30. Okay, minimum you have to score 12, and you will have assignment for 20 marks, and that will be minimum is you have to score is 8. Okay, so in total out of 50 you have to score minimum of 20. And this is SCE, again conducted for 100 marks actually. It's a 3-hour exam, right? So it will be scaled down to 50, right? So you have to score minimum of 18, right, to pass in SCE. And in total, SCE, CI plus SCE, 40, right, you have to score out of 100. Okay, and number of credits is 3, okay. This is LTP lecture, tutorial, practical. There is no practical, there is no lab for you. Okay, non-EC students. For EC core branch students, we have lab. For non-EC students, there is no lab. Okay. And then these things I already told you, right? So these are the major areas of application of electronics and communication, right? Consumer electronics means in washing machine, refrigerator, AC, right? What all electronics devices, equipments we use in our homes, right? So that is consumer electronics. Defense and aerospace, right? In defense sector, radar, aerospace, in aircraft, we got so many systems. We have the landing gear, so many types of subsystems. All are again used are based on electronics devices. Okay, automobile is a whole different sector, entirely dependent on electronics industry. Okay, medical equipments, medical application, all these machines, scanning devices. Uh, Machines, meters, okay, everything, right? All those again are uh, dependent on electronics industry. Okay. Communication and entertainment, okay, telecommunication, especially all your 5G mobile phone, right? All right, again based on electronics and communication. Entertainment, okay, right, like your D2H, all those things. Industrial automation and control, right? So in industry, you will have a lot of these goods produced, mass production, right? Assembly line, we call them as. So that is again based on electronics industry, electronic devices and equipments. You can also control them better, right? And then finally, robotics and automation. These are the major areas of electronics and communication, right? Where EC is used. This is the top 10 largest electronics companies in the world by market cap. You can see all big companies, right? You can see all the companies: Apple, Nvidia, Samsung, right? Synopsys. Okay. And these are the core companies in which our students have been placed. They got jobs, okay, right? So I've included few government organizations and included competitive exams also, right? Because if you study this subject, right, it will be useful for even the competitive exams also, for GATE and for civil services, etc. Okay. These are the major companies. Texas Instrument is our, you can say, major core company in which our students get placed, right? They give the highest package, probably in excess of 20 LPA, right? Robert Bosch also, Samsung, Qualcomm, Micron Technology also. A lot of our students have been placed. Synopsys, Tejas Network, Yokogawa, Foxconn, Broadcom. These are major companies in which students can aspire to get jobs. Okay. So that's it. Thank you. If you have any doubts, I'll be very happy to answer. There is shortage of time. I think Marshall will take over and hand it over to the next department.
Thank you, sir.
Thank you. Thank
Now,
you so much.
now for your next section, we have electrical, introduction to electrical, which will be given by Mr. Rakesh Khanna, Assistant Professor, Department of Electrical and Electronics Engineering. You can start presenting, sir. Rakesh, sir.
Yeah. Good afternoon. Sir Marshall, sir, can you just give me the share option?
So just a minute. Done, sir.
I'll give a raise. Now you can.
So could you do it again? Can you raise your hand again? I made you a present, sir. You can.
Thank you, sir. Yeah. Good afternoon, one and all. Is my screen visible?
Yes, sir. It is visible. You can start.
Yeah. Good afternoon, all the aspiring engineers who have taken admission to RNS Institute of Technology. Myself, Rakesh Khanna, working as Assistant Professor in the Department of Electrical and Electronics Engineering. I have been serving this institute for past 18 years. Today, I'm going to introduce you to one of the ESC course available in the syllabus or scheme of your autonomous scheme, that is Introduction to Electrical Engineering. Code is BESCK 104B if it is in first semester, or it is 204B if it is in second semester. As far as marks and credits are concerned, continuous internal evaluation is, as told by Srinivas Babu sir in the previous presentation, it is for 50 marks, okay, which will have again breakup of 30 marks of written test and 20 marks with assignment and other parameters. Then semester end exam, again, it will be conducted for 100 marks, and the marks, whatever is been scored, will be scaled down to 50. And total for declaring the credit and all those things, it will be summed up to 100 marks, and it is a 3 credit course, as all the ESC courses are 3 credit courses. And coming to the subject thing, let me start with the presentation. So before starting with the presentation, we all know there is no day without electricity. Okay, without electricity, there is no home on the earth. Okay, and even electricity or power sector, what we say, forms the backbone of any country's economy. So country's economy majorly depends on the power sector. If there is no power, probably the world will not move around. That is what is the scenario. So in this subject, particularly Introduction to Electrical Engineering, you will be introduced to basic laws used in DC and AC circuits. You will be able to study the circuit elements, then to explain the construction and operation of machines, major electrical machines such as transformers, generators, motors, then introduce concepts of circuit protecting devices and earthing. Since all of us are using electricity in our day-to-day life, even a common man uses an electricity in day-to-day life, knowingly or unknowingly, there can be electrical hazard. So to at least know what can be done if there is a hazard, at least we should have some minimum knowledge. So for that reason, we have all these concepts of circuit protecting and earthing. Then to explain how the power is getting generated in far remote place, how it gets transmitted to a city like Bangalore, and how it gets distributed throughout the city or some other industry. Then how do we bill? Basically, how we know all this BESCOM billing, how many units for free and all those things. How are we doing that? And equipments and safety measures, personal safety measures. So personal safety, as I told, suppose if there is any hazard in our home, how we can at least act and at least be safe for that particular moment of time till a skilled person comes and takes care of that particular problem. So all these things will be dealt in this subject. Okay, so this is a course objective of the subject Introduction to Electrical Engineering. Then in module 1, we have 2 topics, basics of power generation, transmission and distribution. So we all know there are 2 types of energy sources, renewable energy and non-renewable energy. So in this context, we have thermal, nuclear as non-renewable energy source of energy sources of electricity. Then hydel, solar and wind, they form the renewable energy band. So we discuss these methods of generation of electricity using wind, solar, hydel, nuclear and thermal with the block diagram approach. So now energy got generated and it has to get transmitted. Definitely, I cannot generate, I cannot have a hydel power plant in the center of any city. So it will be somewhere else, some 300, 400 kilometers, and it has to be transmitted and distributed. So how it is basically done? What is the general structure of transmission of electrical energy from generation site to the receiving end will be dealt in this particular topic, and we call that approach a single line diagram approach. That is the first part of module 1. The second part of module 1 is the very simple, which you people might have already learned in your high school and PU, that is DC circuits, where you will be refreshed with basic laws of electricity, Ohm's law, Kirchhoff's law. Probably all these things already have been told in your bridge course by now by another professor. Analysis of series, parallel and series parallel circuits, definition of power and energy, and some simple problems related to this. So the pictures show what all you can basically study in these particular 2 topics. Okay, you can see there is a DC circuit and there are bulbs which are connected in series. So some voltage, if I give, current will flow. You can measure the current through ammeter and you can represent the current as the blue line, which is shown, which we call it as DC's direct current. Okay, this is all about module 1. Coming to module 2, every module we have two topics or two chapters, we can say. We have AC fundamentals and single phase AC circuits. So what all we use in our homes is single phase AC circuit, and how AC system is obtained, or how a single phase AC voltage is generated, that is dealt in AC fundamentals. Basic equation representation, waveform representation of the voltage and current will be dealt in AC fundamentals. As you can see the diagram, that is a sinusoidal wave where x-axis is time and y-axis is magnitude. It can be magnitude of voltage or it can be a magnitude of current. Okay, some mathematics related to that is dealt in AC fundamentals. And application of those AC voltage and current to the circuits. See, any circuit can be broken up as series RL or series RLC or RC or similar circuits. So how, when we give such single phase AC supply, how they behave, how the voltage and current react to that particular device, and how we can evaluate power consumed by these circuits will be dealt in this particular topic. And we have simple problems related to this. That is what is AC fundamentals is dealt. Coming to module 3 is dedicated to what we call as three-phase circuits. Now, whatever I told till now, single phase is what we particularly use in our homes. But what the power level it gets generated in power plants and transmitted and distributed will be dealt in three-phase circuits. It is a three-phase system is nothing but 3 times single phase. So that is three-phase. So in three-phase, we have generation of three-phase, then star and delta, types of connection of three-phase coils, star and delta, relation between line and phase values of voltage and currents in these connections. Then we have something called definition of balanced and unbalanced source and load, power factor, and problems related to this. That is what is three-phase circuits. Now, if I have to clearly tell, the first 2.5 modules are exactly related to the concepts, basic concepts of electrical engineering. The another 2.5 modules of the syllabus or the course is the application of all these things which you might have studied in module 1, 2, and half of 3. Okay, so in this regard, we have three-phase induction motors is second part of module 3. So as the diagram shows, that induction motor is widely used in all the industrial practices. You think of any automation in and around you, in your home, maybe outside, when you go step out, when you go to metro station, malls, anywhere you go, whatever the kind of easy or automation you are seeing is basically because of three-phase induction motor. So three-phase induction motor, how do they work? How are they constructed? And what are its performance parameters, etc., will be dealt in this particular topic, that is three-phase induction motors. Then coming to module 4, again we have two machineries to be learned. One is transformers. So all of you are aware what is transformer. Transformer basically has this wonderful mechanism of stepping up or stepping down the voltage without doing any problem with the power and frequency of the system. So why do we need a transformer? What is the necessity of a transformer? Then how it is working, construction of single phase we are talking, core and shell type. Then some mathematics related to the transformer, losses that can occur in a transformer, and calculation of efficiency, etc., will be dealt in for this particular topic, that is transformers. And three-phase synchronous machine. So I was telling about power generation in hydel, nuclear, etc., etc. So power generation can happen only with the help of synchronous machine, which is the best electrical machine used universally in all the power plants to generate electricity. So how it is constructed, how it works, what are the types of synchronous machine that are in practice in real time, etc., will be dealt in three-phase synchronous machines topic. That is a module 4. The last module, as I was telling, it is completely related to domestic consumers, which we all use in our day-to-day life. So domestic wiring, how the wiring is done inside our homes. Have you seen any wires inside our home hanging around the walls, etc.? How it is done. So there are different varieties of wiring. One you can see outside the wall in this one that we call it as casing and capping. And before the plastering of wall and also we lay some by electrical line, that we call it as conduit wiring. So that is what you study in domestic wiring. Then we have a wonderful concept of two-way and three-way control of lamp. So we all are aware of two-way control, staircase lighting we say, and three-way control, which can be one lamp can be controlled from three different locations. That is how it is working. All those things will be dealt in that particular topic. Then electricity bill of a domestic consumer. So what is your electricity bill says? How you will understand that electricity bill will be dealt in this particular topic. And we also give, there is a topic, small topic called power rating of household connected loads. What is the power rating of your laptop? What is the power rating of your AC in the home? Or what is the power rating of the refrigerator you are using? Or what is the power rating of geyser or something which is there in your, that you know, most of the time we will not know. So we will come to know what can be the power rating. That is what is there in domestic electricity bill topic. Then equipment safety measures. So how are we protecting these equipments which run on electricity throughout? We know very well there is something called fuse and miniature circuit breaker, MCB. These are the two devices which protect the equipments as well as the people from faulty part and isolate the healthy system so that there is no harm or hazard caused for the person or the equipment. That is done with equipment safety measures. And personal safety measures, it is related to electric shock. Okay, so is there anyone who has undergone already electric shock? Quite a few might have gone unknowingly. So how much a human body can withstand a shock? For what duration you can withstand a shock? You'll be studying that. Then effects of shock. Suppose if there is a major event of shock, how it can affect a human person, how it can affect a human body, what can all happen to the metabolism of the body is dealt there. Then how to avoid this shock? It's better always to take precautions to avoid from the shock. So what are the safety precautions we should follow as we use electricity in our day-to-day life without any interruption? So how are we, on what way we can prevent ourselves from this hazard that is dealt in this particular topic. Then one more major important topic is earthing. So every building, every equipment that we use that uses electricity have to be earthed. The purpose of earthing is any unwanted current or discharge of current is silently seeped into the earth without our knowledge, so that we are all protected from its from that unwanted current. Okay, so what are the types of earthing we have? Pipe earthing and plate earthing will be dealt in this particular topic. So this is about the subject introduction to electrical engineering. So as any subject prescribed, this has five modules. And as I was telling about the credit and assessment things, it is the same which is followed for all the subjects. So I hope more number of students will take this particular subject, because as I was explaining, day-to-day life we use electricity, and we should have, at least as an engineer, we should have a minimum knowledge of how to handle a situation when there is a hazard in our home. At least till that electrician comes and takes over, you should have some minimum knowledge so that you can protect your home, your people from these problems, all those things. So I think with this I can wind up the session. I thank Professor Marshall for giving me this particular opportunity to tell about the subject, and I thank even the management and other people who gave me this opportunity. So these are the course outcomes. You will basically understand the methods of power generation, transmission, and distribution scheme. You will be able to apply the basic laws, understand the fundamentals of AC and single phase and three phase AC circuits, features and working mechanism and performance of machines, basic concepts of billing, domestic wiring, and safety measures. And the students who can opt this subject, except core electrical engineering students, all other branch students are open to choose this subject. CS, AIML, cybersecurity, EC, even EC students are eligible to take this subject as their ESC course, either in first sem or second sem. And for core electrical students, we have a compulsory course called Elements of Electrical Engineering and one lab associated to that subject. Okay, so anyhow, you will be studying that. That will be told when you exactly come into the college and start the curriculum. So with this, I thank again. Marshall, sir.
Thank you. Thank you. Rakesh, sir.
Yeah, thank you, sir.
Hello everyone, I am Dr. Lakshmi B. Wali, working as an assistant professor in the Department of Mechanical Engineering, RNSIT, Bangalore. I will be presenting the syllabus contents of the course title, Introduction to Mechanical Engineering. Subject code 24 BESCK 104D or 204D. Contents of the Module 1 includes Introduction, Role of Mechanical Engineering in Industry and Society, Emerging Trends and Technologies in various sectors like energy, manufacturing, automotive, aerospace, and marine. Under Energy topic, Introduction to Fossil Fuels, Nuclear Fuels, Biofuels, Harnessing of Energy Sources like Hydel, Solar Photovoltaic Cell, Flat Plate Collector, Solar Pond, Wind, environmental issues like global warming and ozone depletion. Contents of the second module. Machine tool operations. Working principle of lathe. Operations performed on lathe machines like turning, facing, knurling. Working principle of drilling machine and operations performed on drilling like drilling, boring, rimming. Working of horizontal milling machine. Milling operations like plain milling and slot milling. Under Introduction to Advanced Manufacturing System, components of CNC, advantages, applications of CNC will be discussed, and Introduction to 3D Printing, FDM method. Contents of the third module. Introduction to IC engines, components and working principle of 4-stroke petrol and diesel engine, comparison between 4-stroke and 2-stroke engine, and application of IC engines will be discussed. Insight into future mobility, electric and hybrid vehicles, components of electric and hybrid vehicles, advantages and disadvantages. Contents of the Module 4. Engineering materials, types and applications of ferrous and non-ferrous metals, silica, ceramics, glass, graphite, diamond, polymer, and shape memory alloys. Under joining processes, soldering, brazing, and welding will be discussed. Under welding, electric arc welding, gas welding, and types of flames in oxyacetylene gas welding. Contents of the Module 5. Introduction to Mechatronics and Robotics, Open Loop and Closed Loop Mechatronics System, Classifications of Robot Configuration, that is polar, cylindrical, Cartesian, and jointed arm. Application, advantages and disadvantages of robot will be discussed. Under automation in industry, definition, different types of automation like fixed, programmable, and flexible automation. Basic elements with block diagram, advantages, definition, characteristics of IIoT, and Industry 4.0 will be discussed. Thank you.
Sorry for the error with the mechanical subject students. Now, instead of that, we have with you um, um, Dr. Manohar P, Associate Professor from the Department of CSC Cybersecurity, who is going to engage the last part of the session to explain you about the subject Essentials of Information Technology, which is for the students who are from non-CS allied branches, that is civil, electrical, electronics, and mechanical. Over to you, Manohar sir. You can start the session. Manohar sir, you have to unmute yourself and then you can start, sir.
Okay. Okay, sir. Can you hear me now?
Yes, sir. You are audible and your screen is also visible. You can start, sir.
Okay. Yes. Is my screen visible?
Yes, sir. It is visible, sir.
Oh,
Just move your slides also. I'll just verify if it is moving or not.
pardon, sir?
If you can go to the next slide, I'll let you know if the slides are moving or not, sir.
Okay, okay. Now?
Yes, they are moving, sir. It is okay. You can start, I think.
Okay, fine.
Thank you, thank you.
Dear students, good evening to one and all. This subject is titled Essential Information Technology. So it is very important for students because it gives the foundation of IT. You learn how data is stored and processed, how computer networks work, how software websites are developed, how to use infrastructure responsibly with proper security and ethics. So these basics are essential for higher study, projects, and also for future careers in the field of engineering. Myself, Dr. B, Associate Professor from the Department of ESC Cybersecurity, is going to present today on this topic of essentials of information technology. Yes, these are the course outcomes. So the first outcome, it tells you as to how actually the information can be represented, how the data can be manipulated through various manipulation schemes, and using the IT infrastructure. How is that? IT infrastructure includes hardware, software, uh, other resources. So how these IT infrastructure can play a very important role in exchanging information. That is your course outcome 2. And course outcome 3 is how to apply concepts of software engineering uh, to develop websites and applications. So the fourth course outcome is about the accessing the tables. There are two kinds of
data, either it's a structured data or unstructured data. So if the data is stored in the form of a table, then there will be rows and columns, and how you actually can insert, you can access, and you can perform some operation on the data. So that is the course come forth. In the fifth outcome, you'll study about the fifth outcome is all about the role of cybersecurity and ethics in information technology. So firstly, this is about data storage and manipulation. The module 1 is about data storage and manipulation. So in this, you'll study about data storage. Everything is presented in the form of bits. A computer stores the information in form of bits. And also, there are so many components of computer, like say the main memory, which is very fast. It's volatile because whenever the power goes off, the data is low. But it's a temporary memory, but it is very fast. And there are other mass storage devices like hard disks, the solid state drive, optical storage devices, which are permanent devices. They are non-volatile. And information, either an image or a text or a number, okay, all this kind of data can be stored as patterns of zeros and ones. These different data can be represented as bit patterns, and also the computer uses base-2 system because there are so many number systems. Okay, you have decimal, you have hexadecimal, octal, etc. So, but the computer uses base-2 system for all its computer operations. And how actually you can store the integers. So the integers, the positive integers are stored directly in binary form, whereas to store the negative integers, you have to use 2's complement format. Okay, then also the storing fractions. So the fractions can be stored using the fixed point format, or you can store it using floating point format. But the floating point format always follows IEEE standard. And how is that you are able to manipulate the data through computer? So therefore, the data is acquired and then it is processed. So this computer architecture defines CPU, memory, IO structure, and you know what machine language is. That is at the lowest level, the computer is able to understand only the machine language, and these machine languages are I mean, the machine languages are written or they are formed using instructions written in binary. And when you run a program, the CPU will have to fetch the program from the memory. Okay, it has to decode the instructions. That is, it has to fetch the program. That instruction after instruction, it has to fetch from the memory. It has to decode it and then execute the instruction. So therefore, it has to follow this fetch, decode, execution cycle, and many arithmetic and logical operations can be performed. Arithmetic, you know, plus, minus, multiplication, division, logical operations like AND or NOR. All these operations can be performed on the data. And also these devices, the computer also communicates with external devices through IO operations. So this communication is managed using bus controllers, device controllers and system buses. Then model 2 is about operating systems and algorithms. So here, after studying the history of OS, starting from simple batch systems to presently used multitasking systems, you'll also study about the OS architecture, which consists of 3 main parts. One is a kernel, which is at the core, and then there are system calls which link the application programs to the OS, and then there is user interface. So all these are designed using different techniques like monolithic, layered, etc. And the activities within the computer can be coordinated and controlled. Uh, how actually the activities are coordinated within CPU, between the CPU and the memory, between the memory and storage and the IO devices is what you learn here. And also, the processes keep competing with the resources. So how actually this computation of the processes uh, is managed. That is what you learn here. So security, data and resources can be protected through authentication, authorization, and access control. So OS offers security, you know that. So security is the key issue, the key concept for OS. Sorry, key feature of OS. So therefore, it protects data and resources through authorization with control. So algorithms. I also will be studying about algorithms, how actually you can solve a problem using a step procedure. Uh, in algorithm, you write steps, right? So step by step, how is that you will be able to solve a problem, and how actually algorithms can be represented. It can be represented in various ways. Okay, so very importantly, you can be represented either using pseudocode or flowcharts or natural languages. So and also how efficient algorithm you can design to solve a problem. So that also you will be studying under algorithm discovery. But yeah, it needs creativity, it needs logic, and also after writing an algorithm, after designing algorithm, how actually you can optimize it in terms of time and scope. So that also we'll learn. Then network is cybersecurity ethics forms the third module. So networking it is a collection of connected devices. Many devices communicate with each other through network. So there are two types of networks: LAN and WAN, local area network and wide area network. And also the internet is a very largest WAN, which is a network of networks through which you can communicate globally. And World Wide Web, so here the information can be accessed through web pages, browsers, and hyperlinks. So then to uh, for the communication to happen over the network, some protocols will have to be followed. Very important protocols which are involved in network communication are TCP/IP, HTTP, FTP, DNS, etc. And security is one. So how actually the data and the users can be protected uh, through firewalls, encryption, and authentication is what we'll study here. Then coming to the ethics, this is moral principles you need to know how to use the technology and how is that you are responsible for the data, privacy, and rights, all these things. You'll be studying about IPRs, ownership rules, okay, copyrights, patents, trademarks. Okay, so how to create a content and how is that you can share a content with responsibility. How is that you'll be able to do that? How to avoid the misinformation, cyberbullying, and if you always avoid speech. So all these ethical values, so the ethical values to be studied here. So then software engineering is, here you have so many methods which can be used to design, uh, develop, and test not only the design, test, and you can even use the various softwares through software engineering. So how to design, develop, how to test and maintain the software is what you learn here. So there are so many cycles. There's one cycle. So you design, you implement, you deploy, and you maintain the software. So this software development will study here, and so many methodologies used software engineering is like waterfall, agile, and all this. So the advantages of both methods will be seen here. So then you have databases. You have what databases. So you need a backend to store the data. So how to update the data, how to access the data, and the DBMS is used for accessing the structured data. So there are so many tools available to store the data, to query, and so to secure the data. So also you have to take care of redundancy and concurrent access will be there from the database. So the advantages, these fundamentals and advantages of data. Relational model, RDBMS. So what is a key? Because without a key, you cannot establish the relationship between the database user. So represent data in tables. Okay, so usually structured stored in RDB, but there is a language called SQL which can be used to retrieve the data. So how we can develop websites? What is HTML? What is the difference between CSS, which is cascading style sheets, and HTML? All these we'll be studying. How actually we can develop a website using the HTML and CSS, and also how we can structure out a website. Okay, well, how to design a page, navigation, content pages, and also how to use JavaScript for more interactivity, for to increase the interaction, uh, user interaction with the website. So we'll have to use JavaScript. So how to do that? Computer graphics, how to create a visual content using computers, how you can create, you can manipulate visual contents. Some of the applications of computer graphics are gaming, animation, CAD, virtual reality, etc. So then we're studying about 3D graphics, not just 2D, 3D also. How to extend 2D graphics to 3D, and this graphics is how it can be used in movies, virtual reality, scientific visualization, and how to build these objects using the geometrical shapes and mathematical representations, all these things. And even 3D can be converted to 2D images. So that is what is called as rendering. So all these things, the effects, the textures, the shading, lighting part, so everything is involved here. So that's about the model. So this uh, particular software helps students build a strong foundation in uh, how computers store and process data, how computers and networks can work together, how the devices can communicate with each other effectively, and how the software and websites can be developed. Uh, that's what I told him. These basics are essential for higher studies, for carrying out your project work, and also it is very much useful for your future careers in the field of engineering. Uh, so also you'll learn security issues also. So how to use this IT infrastructure very responsibly, ethical part. So all this will be learning subject. So that's all my side, and thank you for your patience and listening. Sir?
Sir, thank you, sir. Thank you, Manohar, sir.
Thank you.
Students, because of some technical issue with Jagannath, sir, I think Introduction to Mechanical course session will be done again tomorrow. We'll let you know about that in the WhatsApp group. Thank you for joining today. The recording of today's session will be shared to you so that you can again go through that, and the PPTs, whatever it is, will be shared to you also. Thank you for joining.